Who is Vishal Ghariwala, and he's the CTO, Chief Technology Officer of SUSE, which is very famous and probably well known for their Linux distribution. But he's going to talk to us today. I mean, we've all heard about how ubiquitous APIs are, but it's also really important for them to also run ubiquitously across different platforms, cloud native, on-premise, in the data center, and run anywhere. Vishal, please welcome in joining him to the stage.
Testing, testing. Am I audible?
Yes.
All right. So very good afternoon, everyone. I do see people streaming in. It's great to be back here after almost 4 years. This is my second, I would say, presentation in Australia. I was here in Sydney 2 months back for the CIO Summit. But I'm just impressed by the amount of crowds that we are seeing back in the conference, and especially, it's really fun getting all those goodies. Thanks very much for your presence. So, we have heard a lot about APIs. I mean, not just today, but we have been hearing about APIs for a long time, and there are a lot of reasons why companies adopt APIs. But one of the primary reasons is all around business agility. How do I get my products to market faster? And obviously, APIs provide a lot of benefits for you to get there quickly. In my opinion, a lot of times, we often tend to ignore the other part, the other side of things, which is the infrastructure that is absolutely critical to help you get your business goal, to help you achieve your business goals. And that will be the central theme of my presentation today. So to illustrate what I mean here, I'm going to, let's see if I can click. I'm going to do a history of APIs. And I mean, there are different versions to it. This is based on my understanding. And if you look at how APIs originated, they have been here for a very long time. In fact, in the 1960s to the 1980s, during the world of the the age of the mini computers, as well as mainframes, APIs existed, albeit in a different shape and different form. So back then, we called them subroutines. I've never used Fortran before. I was taught about Fortran in school, but I believe some of you may have had a chance to use Fortran. But it was during that time when we also saw the invention, I would say, of the credit card machine, where basically what you're doing is invoking some subroutine control. So that's a type of an API. Then we moved to the 1990s, and this was the domain, the era of client-server and distributed computing. And really, this is where we saw a lot of the Windows technologies. I used a lot of DLLs back then. I was in the university. I liked them, but I don't know why people call them DLL hell. And then towards the later part, we saw the emergence, the rise of Java, and that's when we had XML, remote procedure call, towards the late 90s. And I had a chance of playing that for a while. It wasn't easy, RPC, if those of you have tried that. Then we moved to the dot-com age, 2000 to 2010. And this was the time when we saw the rise of the internet, as well as another technology that revolutionized the way that we build infrastructure, and that is virtual machines, right? VMware and the rise of virtual machines. And then we had a new type of an API format. We had XML over SOAP, XML data format using the SOAP protocol, and we commonly call them web services. And that was really powering the age of the internet, the rise of the AWS of the days. Barnes and Noble, they're no longer around, but these are the companies that really leverage all of these technologies. Then, 2010, the rise of the mobile companies, the analytics companies, the public cloud providers. Then we had another type of API format, JSON payload on REST services. And then today, as we speak, we have a completely new type of an infrastructure landscape composed of on-premises infrastructure, hybrid cloud, multi-cloud, and as we speak, edge and the beyond. And therefore, we have different type of APIs as well. We have open API format, we have GraphQL, we have gRPC, and I know there are some vendors going to talk about that. So APIs have evolved, but if you look at the infrastructure has also evolved. I would argue that the API formats have been created so that they are aligned with the new infrastructures, so that they are supporting so that they're able to leverage a new infrastructure. I mean, I'll give an example of the 2000s, right? Look at web services. One of the best thing about web services is riding on HTTP. It doesn't matter what type of virtual machines your program may be running, you just need to expose HTTP and everything is possible. And today, in today's times, we have a lot of these new specifications and standards like GraphQL, gRPC. Why? Because we have new use cases like streaming use cases, and we also have use cases where we need low latency, and therefore GraphQL makes sense. Obviously, there are other things like open banking, TMF forum for telcos, where we need open API specifications. But you will see that there has been a close relationship between infrastructure and API types. And as we talk today, one of the most dominant infrastructures of today's times is cloud, and customers are embracing the cloud in a very big way. There's this Flexera survey that was just released today that clearly shows that over 80% of customers are adopting hybrid cloud, and close to 90% multi-cloud architectures. But note that it's not just using them, but they are using more of each. So the chart on the right side shows how many of each, how many public clouds and private clouds each customer is using. So clearly what is very evident is that everybody is using a lot of both. And when you have all these options available, then customers will also want to maximize. And that is why from an API angle, one of the trends that we see is that customers want to have the ability to run their APIs anywhere. All right? They want to be able to deploy their APIs flexibly on all the infrastructures that are available to them. And this is a screenshot from last year's Google Cloud's State of the API Economy report, which says that 50% of customers, there will be an increase in hybrid cloud adoption in the following years. Hybrid cloud, because you are already having a hybrid cloud infrastructure. So how do I maximize the infrastructure that I have available at my disposal so that I have all the scalability benefits? So that is happening. The other reason could be more from a technical architecture angle. Some APIs are best suited to be deployed on premises because of data sovereignty, data sensitivity, data security, and others could be deployed on your public cloud environments. But API deployment flexibility will be key and central to any API strategy, API program that you rolled out. It will be critical to its success because today APIs can live anywhere, from the data center to the cloud, and even at the edge. The other thing that we also see, because of the fact that we have a distributed and heterogeneous architectures, is this thing around customers wanting to mix and match their API infrastructure, primarily your API gateways. And what I mean by that is, and I have personally seen, the customers who may be using an API stack from one solution, one team is using that, and another team within the same organization is using an API stack from another company. And why do they do that? For a variety of reasons. It could be due to their preferences because they're skilled in that particular platform, or it could be they acquired another company and they just inherit, or it could also be due to not being locked into a particular vendor. Obviously, vendors will tell you to use solutions from their own company, but this is a phenomenon that you cannot stop. Customers want freedom to choose whatever solutions they like, and they want to have the flexibility to mix and match. But at the same time, I'd argue that while you have the freedom and flexibility, you also need to be able to do all of this in a consistent manner, because freedom without consistency, flexibility without consistency will not translate into agility. But this is something that is happening, and part of it is because of the distributed infrastructure that is giving rise to this distributed API infrastructure that you see today. So if you look at it from another angle, what are the different types of solutions that APIs are driving today? And a lot of this, you may have seen this, but I'm painting this from the vantage point of API development. First of all, today everything has to be a service. Correction, everything has to be a managed service. We want somebody else to manage it for us. And what that really means is that, forget about internal libraries, internal subroutines and blah, blah, blah. Everything now needs to be a microservice, containerized, exposed as an API. That means a lot of API endpoints, and that's why you have the rise of the API management solutions. They have been around for a while, but the newer generations, and as well as service mesh, because there's this explosion of microservices. There's also changing customer demands. Customer wants to translate an idea and get it into production in the shortest time possible. And really here I'm talking about APIs, and how do you get your APIs to production very quickly? We see the rise of DevOps, CI/CD toolchains, and so on and so forth. Obviously, when you make all of these services available to the public, you're going to see a rise in traffic, rise in consumption, and therefore scalability becomes key. And here is where we are seeing the shift towards a distributed and heterogeneous architecture. And that also presents new challenges, right? How do you then centralize this environment, get a single pane of glass perspective, and how do you manage it centrally, right? So there are some new solutions around there as well. And finally, around agility and interoperability. And this is where we see a completely new design pattern. We are moving from bare metal, VMware, containers, and Kubernetes. But then Kubernetes itself, we know it's not simple, it's very complex. And then when you put hybrid cloud, edge, multi-cloud into the mix, it becomes very complex. So simplified operations is going to be something that you will need. What you see on this red box here, this is the area that when we talk about API development, API technology, this is the area that we often tend to overlook. We do look at it, but more from an API management, API infrastructure angle, but not end-to-end. We do not look at it from the entire ecosystem angle. And how does the ecosystem really look like? It stretches all the way from your compute infrastructure, which today can be anywhere. It can be on premises, it can be on your multi-clouds, your public clouds, it can even be on your edge environments. And that is basically your compute that is going to be providing you all the resources to run your APIs. On top of that, today, we have this abstraction layer that allows you to abstract your underlying compute infrastructure. And we know the winner is Kubernetes. There's just one technology out there that is supporting all these cloud-native requirements. And on top of that, then we have other technologies that are going to be leveraged for orchestrating or for choreographing microservices. You have service mesh. And on top of that, managing your APIs. This will include your full API management, life cycle, right, from rating, throttling, security, developer portal, and so on and so forth. So all your connectivity and governance capabilities. And only after that, you'll be able to provide your APIs as a digital service, which will then be consumed by your digital channels. Could be your customers, could be your partners. It could be even another API from another partner or customer that is consuming your digital service. So this is your entire ecosystem, and this is what you need to keep in mind when you roll out API projects. And central to it is Kubernetes. It's that one thing that is not going to change. Let me put this in another way. 5 stages of cloud-native APIs. This is my interpretation on some of the work I've done in the past 5 to 10 years on APIs. And I mean, this could be 5, this could be 10, but at a high level, every project will start with the first phase around development. This is where you develop your APIs. The underlying language could be varied. It could be Java, Node.js, Scala, blah, blah, blah. But then you're going to, today, if it's going to be a cloud-native API, you're going to run it in a container, right? And then you have everything else happening. You have development, management, publishing, and API consumption. The thing that you see here is that Kubernetes is all across, the entire 5 stages, entire 4 containers, and then the rest of the 4 stages. You're going to deploy your APIs in the Kubernetes environment. Your API management infrastructure is going to run on Kubernetes environment. So is your developer portal. And then, how you're going to consume it, that's potentially going to be there as well. So if Kubernetes is a central piece, then it becomes very critical to ensure that we have a consistent way of, managing it in an environment that is so distributed. So I'm going to give, before that, what I want to share here is today it's a given. The world that we are running today, the cloud-native world, it's a Kubernetes world. So this is from this is very small, sorry for that, but it's a CNCF survey from 2021, the most recent one, where it shows that 96% of organizations are either using or evaluating Kubernetes. So it's a standard, right? I want to have a show of hands for those people in the room here. How many of you are using more than one Kubernetes distribution? Okay, I see some, but I think some of you internally say yes, but maybe you're not raising the hands. But then, based on what I've seen, right, I like to correct myself. It's a multi-Kubernetes world, right? There are multiple distributions running, and that will happen by choice, or that just happens naturally because of the way your organization evolves, its strategy evolves, because of the preferences of internal teams. It becomes a multi-Kubernetes world. So I want to present a scenario to you of what is one way of approaching this. So take a look at this, right? So you have the orange shaped HUD, that's your on-premises data center. And then green is cloud, your public cloud providers, and then what you have on the right is your edge instance. And you are a customer, you decide, okay, let's go cloud native, big bang, let's do cloud native in a big bang way. So what you want to do, first of all, you want to make sure that, okay, let's get Kubernetes running everywhere. So on premises, you may want to use, you may want to download from GitHub, or you may want to use, for example, Rancher Kubernetes engine, and then you can use AKS, EKS, GKE on the cloud. And then you have another version of Kubernetes that is certified and tested to run very well on edge environments like K3s, low footprint, good for the edge. All right, so you have all this set up. A lot of different environments, a lot of different Kubernetes distributions, and it's an intricacy because how you run it and manage it and operate it on AWS is very different from how you do it on Google. It's very different from what you do it, how you operate it on Azure. So then what you do is then you deploy all your workloads, right? Your workloads can be a mix of a lot of things. Could be your cloud-native microservices. It could be your API ingress controllers, your API gateways, your service mesh, and so on and so forth. So you deploy them, and it's a mess, right? So many things, so many environments, and this is where what SUSE, as a company, we have a solution to help you through an offering that we have in the market known as Rancher. So think of it as Rancher as an abstraction layer that helps to hide all the complexity around managing multiple distributed Kubernetes environments from a single pane of glass, and at the same time providing you with one singular console that allows you to apply a lot of the value-added capabilities, such as governance, such as centralized policy management, and also providing you with a lot of the DevOps type of capabilities. This basically simplifies the way that you are going to roll out your infrastructure for the APIs that you're going to be building. I have another diagram here to really explain a little bit deeper as to what Rancher really does. Today we have a distributed landscape, a lot of different Kubernetes distribution that you may choose as a customer running on your preferred operating system. Rancher basically sits on top of that and hides all the complexities so that as a customer, the way that you manage, operate, provision a Kubernetes cluster on AKS, EKS, GKE, it's all the same. It's going to be all the same. And at the same time, you are going to be able to add a lot of security, policy, governance, and management on top of the environment that you have built so that you focus on what matters to you, which is building your APIs, getting your API infrastructure up, and powering your digital services. That's in a nutshell what Rancher allows you to do. I have two examples from an API architecture angle where this fits in. So one of the common constructs, right, when you're defining an API architecture is your gateway, your ingress controller, where you have your untrusted traffic that could be your external API consumer that goes into your gateway, and then the gateway will consist of your controller, your proxy, and it routes your requests across your services. This is just one Kubernetes cluster, but there can be multiple Kubernetes clusters distributed across a heterogeneous environment, on-premises, public cloud, and it could look something like this, right? Many. And this is where Rancher what Rancher allows you to do is don't worry about all of that, hook it up to us, let us manage, and on top of the management, we provide all the operations, governance, enforcement, and security capabilities for all the API gateway clusters that you're running. Another example that I have, and this is a screenshot that I've taken from solo.io. I think they are presenting, but I'm using this as an example. This is the example of a federated service mesh, hybrid and multi-cloud service mesh applications where your service mesh is federated across multiple clouds. And I like this because here in this architecture we are using a mix of a gateway combined with a service mesh, and there are multiple clusters. As you can see, there's one on premises and the cloud, and then there's one on Rancher as well. And the concept is the same. Basically the concept is the same. We have Rancher managing everything for you, and this is critical because while, as in the previous case, you have your API management solutions that takes care of all the federated capabilities, what about the underlying infrastructure? Because if your underlying infrastructure is not able to be provisioned as quickly as your API infrastructure, your agility requirements are not going to be met. All right, so this is what, in my opinion, a modern API infrastructure looks like. It's going to be based on Kubernetes management. That's where SUSE and Rancher can help you with. Then you have the API, the service mesh layer, which will also need to provide some level of management. Remember, in a hybrid multi-cloud world, management is going to be absolutely essential across the stack. Then you're going to have API management layer, API infrastructure layer. And only then you have your consumer, right? So the bottom three are going to be absolutely critical. And at the end of the day, what you are really going to get is this single pane of glass that Rancher provides you with, so that you have a singular way to view your clusters, to manage your clusters, to secure your clusters in a way that is very, very agile. I actually have a couple more slides, and I know I just have 3 more minutes. I may not be able to take questions, but we have a SUSE booth out there. But I want to spend maybe 2 minutes talking about us, SUSE. We have been here for 30 years. We celebrate our 30th anniversary this month. And we are powering some of the largest customers across the globe, across the various sectors that you see here, across the various verticals. And basically, it started off in Linux, SUSE Linux Enterprise, and now doing a lot of things in the container space, container security space, and also in the edge space. A lot of work we are doing in the community as well. We are partnering with a lot of community projects, foundations, Linux Foundation, CNCF, and so on and so forth, and a lot of customers across the world in multiple areas. So I would say that we had a fantastic presentation this morning by the gentleman from the university, the professor, right? And I completely agree with him that the future presents a lot of opportunity for us. Things like Web 3.0, decentralized finance, things like the metaverse, all of these different use cases will require APIs. API is going to be central to all of this. Be it your digital twin in your manufacturing firm, or being the doctor that you see here who is doing this operation, it's going to be powered by APIs. And obviously, who can forget? Who actually can forget API? AI. So if you see this cake, right? This cake. I actually used an open API, an AI API to render this in the style of Vincent van Gogh. It's similar to DALL-E. DALL-E can also do that, but I didn't use that. But this is done by APIs. I have also created the abstract for my presentation using GPT-3. I didn't write it myself, and the GPT did a better job than me when coming up with the abstract. But these are the potential. These are the future potentials, and API is going to be absolutely central to it. That's all I have. I'm not sure if I have any time for questions. I don't have, but I'll be at the booth. Thanks very much for your time. Thank you.